All right, well, we got about 45 in here, so that's awesome. So before we, yeah, good. I'm glad to hear that, Anthony. So before we go get started with this, I wanted to tell you guys that, yes, I am sad that this is our last class together because I really enjoyed our time. You guys are a great group of students. You're definitely motivated, and I really loved the participation. And I hope you guys have a wonderful rest of your journey here at Lambda. And I hope to see you on the hired channel not too long from now. And as always, I'm going to be here for a while, so feel free to always direct message me. I never hate to look over your code if I can offer a second pair of eyes. So feel free to reach out to me if I can ever be of help. And with that, let's get going with classes. Oh, I need sound. There you go. Whoa. All right, so it kind of is, Anthony, right? Well, and you guys are going to be taking a big step in subject matter too, I think. So once you get out of here, you're going to go into, well, I don't have it up, but you're going to get a lot more into the JavaScript programming, I believe. So you'll learn more strategies of JavaScript, how to do more advanced things, and of course, you're going to learn how to build some pretty cool applications. Yeah, there you go. Yeah, React, right? You're going to get React. I think Redux, you're going to get into as well, I think. So that'll be interesting stuff to learn. It's going to give you a framework for how you take all this little piddly JavaScript stuff that we've been doing and how you put all that together strategically to create an actual system, an application. So it's going to be really exciting for you guys. Okay, so let's get started. First one, you guys, we're reviewing. Review. Give me anybody, and you can just make it as generic you want or randomly specific as you want. Give me the format for constructor function. Start there. Nice. Function fruit attributes as your parameter. This dot name equals attrib dot name. Fantastic, Carlos. Nicely done. Yeah, there you go, Gina. Excellent. There is no, Greg, there is no constructor keyword. It's just a function with some weird formatting. Nice job, guys. So excellent. So let's get our first constructor function going. So we're going to make this one a generic animal. Nice and easy with just a single name attribute. And all right, there you go. So this dot name equals name. First interest. This dot name is equal first last. You're getting all fancy, Jonah. Nice. Awesome. Excellent. Yeah, function tree h type height, set this h, set this, there you go. You guys got it. Nice. Awesome. This dot description equals generic. Well, it'd be attribute dot generic or just attribute, but yeah, good. All right, so you guys got it. So that's creating a basic constructor function whose sole purpose is to instantiate an object. Nice, Anthony. Just forgot your planet, unless you're grabbing you're doing some, which would be okay. That would be legal there, Anthony, to do some closure to reach out and grab the planet data from global space or the outer space, but just be careful when you do start doing that in object-oriented programming. All right, so let's get this one going. So we're going to have name, this dot name, super simple. Boom. Actually, oh my gosh, I'm not done. Name. So real easy, not too complicated. And then we can add as many of these attributes as we want, pointing them all back to this, so that whenever we refer to any of those attributes, either we're going to be within the object using this, or we're going to be outside of the object using the dot operator and whatever actual instance object we create from that, which we'll create here in a minute. Now, okay, so next one is add a basic speak function to the prototype. There you go, Jonathan. Nicely done. All right, so now give me add a basic speak function to the prototype. And you don't have to do the internal parts of the function, just the outer surrounding, unless you want to. There you go, Carlos. Nicely done. Nicely done, Gina. Well, I think Carlos is the closest. Gina, you gotta have a function, some kind of function declaration there, but pretty much everything else is right. Animal.prototype.speak. Bernard, good, but when you set the speak using prototype like this, you don't include those parentheses because we don't want to invoke it, because that's what would happen there. The system would try to invoke it, then it would see the equal sign and freak out. Yeah, absolutely. So let's, at least I think yeah, we can use the arrow function because it's going to be an anonymous function anyway that's being assigned to speak. So, all right, so we got animal dot prototype dot prototype, and then just the name, because again, we're not invoking it. We're going to assign it a function, and we can do a basic arrow function like so. And it's going to be just return. And then we can say return $, this dot name says hello. Nice and basic, very generic, because he doesn't even have a say yet. It's just an animal. There you go. Nicely done. Excellent. So, yep, console log, perfect. That's like I said, be aware of that issue of directly interacting with the interface from within those objects, but that is, like I've said, there are times where that is needed and wanted. Perfect, nice. So yeah, we're just going to return that. So that's actually, let's also go ahead and set up my preset. Let's do const log is equal to console.log. And then, nice. So now let's go ahead and call it. So we'll say log. Oh, we can't call anything. We don't have an object yet. Because we got to create one now. So now, give me the format to create a dog using, or actually no, let's just make a generic person using this animal constructor. So what's the basic format for initializing an object using the animal constructor function? Remember, and don't forget the new keyword. Let's do person1, I'm going to say equal to nice. Nice, although you got to include the parameter. Although did I tell you guys about the default parameters? I think I did. It was briefly at the end of the session. But remember, you do have a default parameter option. So perfect, yes, very nice. Constant dog or constant whatever equals, and then new, and then we call the constructor function, making sure to pass in the necessary data. So in this case, let's just do Nathan. Nice, const dog equals new, and then the constructor. Excellent. All right, so that creates our object and instantiates it in memory. It runs through this the function, the constructor function, sets up our attributes in the object. Then it sets up the prototype, well, the speak option on the prototype for that object. And so now we can call, give me the command to issue or invoke the speak function for person 1. And we're going to log it too, so don't forget that. Remember, we're invoking it. Don't forget your parentheses. Nice. You guys got it. Person 1 dot speak and the parentheses. Nice. And of course, we're going to surround that with a log. Hopefully nobody's making the mistake of trying to use log later on and be like, why isn't this working? And forgetting about this command. My superiors are probably going to tell me to stop doing that. Oh well. Nicely done, guys. Excellent. So that's pretty much it. That's creating a basic object using constructor functions. So, hang on now. What's going on? Oh, I didn't pass it. No, I did pass it data. Create a new animal with the data Nathan name, going with the name into this. The only thing I can think is maybe there's a problem. Yeah, that's the only thing I can think. I've had similar situations where for the life of me, I couldn't get the arrow function to work. So I guess the answer is no to who asked that question. Arrow functions aren't functioning. They don't function when creating objects like this. So yeah, so that's the other thing is, yeah, just use the basic function declaration when you're dealing with objects. Okay, so let's rerun that, save, run. By the way, let's give you that link there. Okay, so Nathan says hello. Very basic. So remember what's happening here. We've got our person 1 and then the dot operator, which means we're binding or implicitly binding person 1 to the this keyword. So then when it calls this function speak, this is pointing to person 1. So person 1 dot name says hello. Now let us. Okay, so let's inherit. So we're going to do inherit the object onto a child using the same methods, using constructor functions and new keyword. All right, so we're going to create a new one. This one's going to be a dog. So we'll just keep it, we'll do function dog, just like normal. Let's go ahead and let's give it, it's going to have a name, and let's say, let's do this. Hang on. This stuff, skills, object.create object. Well, let's actually just, yeah, so let's do name and nothing else for now. I'm going to show you some other stuff here later. So, okay, so function dog, just pass in the same attribute. And we will say this, nope, hang on. Function dog type this equals type. Yeah, so that's going to be the basic, but we need to inherit first. So the first step is to inherit from animal. Remember how we do this? There you go, animal dot call, fantastic. This object being bound back onto the call function, and then we pass in the attribute. So that's going to call our call the animal constructor, which is our parent constructor up here, our parent object. It's going to call it, and then we call it by rebinding it to this object, dog, but running it through, these commands. So we have dog.name is equal to whatever got passed in. So that sets up all the presets from the parent. But now we can create our unique attributes for dog. There we go. So now we create our own. So in this case, let's do a const skills is equal to an empty array. I'll show you how we can use that to have an endless list of skills that we can add to for this dog. So now we've inherited the original object from animal onto dog. We've added our own skill or our own unique attribute to dog. So we've created a more defined object, which inherited from the more generic object. So the further down the hierarchy you go, the more specific your objects should become. Now, we need to inherit our prototype from the parent, from animal. How do we do that? This is the weird one. Remember that function call, the object dot what? So of course we'll start with animal dot not animal prototype. My goodness. There you go. Yeah, it's gonna be option dot create. Oh, you know what? You're right. What am I doing? Thank you. That would have given us an error much later. Nice eye, Bradley. All right, so yeah, we're gonna say dog.prototype is equal to. So we're gonna overwrite the dog prototype, which currently has nothing in it, or it has all the default that are in object.prototype, so it was inherited from the system object. So there is stuff in prototype, but right now it's just generic. It's just a generic prototype. So we need to override it with the prototype, which has been customized from animal. Nicely done, Gina Claire and Carlos. Dog.prototype equals object.little_create. That tripped me up the other day. And then we assign that, yes, the animal.prototype. There we go. I've been using my tab autocomplete in VSC all day, so that's why I'm having to double check my typing. So yeah, perfect. So that's going to take it calls the function object.create. So it creates a brand new object using the object we pass in, which is our animal.prototype. And then it passes that back into and assigns it to our dog.prototype. So we pretty much just overwrote dog prototype with animal prototype. Which means, quick question, if I added a custom method to dog right here, would it still exist after line 28? If I added a dog.prototype let's say say get skills, and I assign it to function, and then returns whatever. So Carlos says no question marks. Seth says no question marks. Has no idea. Amanda says my gut says no. You have a good gut. Yeah, methods are functions. Yes. Yes. Anthony says yes. Interesting. No. Most of you guys got it. It is no, because we are overriding our dog.prototype on line 29 right here. So this overwrites the entire dog.prototype object. Yeah, so it's going to overwrite the entire thing. So whenever you are customizing multiple layers of objects in object-oriented programming, you do want to be careful, because if you do assign special functions, unique functions to an object, you got to do that after you inherit the parent. Now, the beautiful thing is what we're about to get into is you don't have to worry about that anymore. We'll get there. All right, so we got this here. Thank you, Jesus. Yeah, exactly, right? Okay, so let me finish this. So log skills. So let's give this an actual full function. Let's go ahead and write this out real quick. In this case, I want it to get the skills. I want to log the skills. Let's just say log skills. So I want it to go ahead and report everything from that. Yeah, exactly, Bradley. Object, the capital object in JavaScript is the parent of all of our objects. Everything from our arrays to our variables to everything else. That's actually the parent, way up there or way down there in the family tree, not up. Okay, so let's log this. So if this .skill.length is, let's see, let's do less than 1. We're going to say, we're going to directly, so this is going to be one of those cases where I'm going to directly log to the interface. And the reason is because I have said log skills. So I want specifically to log this dog's skills or this object skills to the log. So in this case, I am going to have a side effect. I'm going to tell it to log. And so if this .skills.length is less than 1, that means it's 0, which means poor guy doesn't know any skills. So we need to teach him some. But if he does have some skills, then we will say console, let's just do the log, let's say $ this dot name, and then we'll do this dot skills dot for each, and then we're going to say S for skill, why not, arrow, and then we're going to return our log S for each of those objects. So it's going to report every skill that the dog learns. Now we're going to create some functions down below to actually train the dog later. Well, actually, wait, where's my train function? There it is. Okay, so we'll write that here in a second. So that's how we can report our objects array. Now you think about that, you know, you've got an object here that has an array, and we're going to write a function that allows us to put stuff into that array, kind of like we did with the project on objects and inheritance. You know, you can build essentially that as a collector placeholder, so you can add as many elements to that skills list. And think about that with, what if you got a person like a manager who's responsible for multiple employees? That would be a great way to show that structure in your objects. You could load all the employees into an array as objects into the manager. So that way the manager, you know, has a link to all of its employees. All right, so this, let's go ahead and run this and make sure we're good. Let's clear and run. Gotta call it, buddy. And of course, we gotta create our animal. So in this case, let's do const dog1 is equal to, and then we're gonna do a basic new dog, and let's make this one Axman. Axel. All right, so there's our dog, and we're gonna say dog, now log, so log is already there, so I'm just gonna say dog1 dot speak, nope, log skills, pay attention to Nathan, log skills. There, so now we should get the response, doesn't know any skills. There you go, actually does not currently know any skills. So last one here, let's add another prototype function here, and this is going to be a method to train the dog. We'll go on break, and then we'll do all of this again using classes. So we're just doing a full review here, giving you guys a couple of good examples. All right, so now we're going to say for the dog, let's say dog.animal, what am I doing? Dog.prototype dot train, and we're going to say skill. Oh my gosh, what am I doing? Hang on. I did this so many times yesterday. No arrow. And then, okay, so now we'll say this dot skills dot push, and we'll push the skill right onto the skills list. And then we can say, well, let's do a verbose response. Let's return. Now, I actually have a reason why I make this a return. So I return this statement, $, this dot name has learned $skill. So think about this. Do we really have to log this? Is it really necessary? Right, it's not. So the reason I did that is I wanted to show you, again, back to the side effects rule, the whole side effects thing, you know, avoid side effects in your objects methods. And so by avoiding logging that directly to the interface, I give the developer, if the developer wasn't me, if it was someone else, or if it's me, I give the future developers using this code the option to make it verbose or not. So some functions do that. Some functions will take an object, modify that object, and it doesn't have to return it because it's an object with a pointer, but yet it does return either a true or a false, saying it was successfully modified, true, or false, there was a failure. So you don't have to do anything with the true or false, but you can use it for logic control, error controls, or just the choice of whether or not I want the system to be more verbose, or if I want to, you know, shut up and just do the work, right? So that gives you that option. So that's why sometimes it's better to just return the report like that as opposed to just directly logging it. Okay, so we'll say, let's clear the screen. We're going to log, there's no skills. So then give me the syntax to train a skill for dog1. Come on, guys. We want to create. There you go. Nice. Come on, let's get some other skills in there. I'll type them in. Dog1 dot train sit. Excellent. Dog1 dot train. Oh God. Oh Lord, I shouldn't have said that. And then, all right, so let's copy and paste. All right, so what else we got? Follow, nice. And roll over. Why am I capitalizing that? All right. And of course, speak, nice. Okay, good. All right, that's enough. We got to go to website. Hey, let's do that. Axel's pretty smart. He could probably do that. I mean, he is a border collie, for goodness sake. The only thing smarter than a border collie are poodles, the full-size poodles. All right, cool. So we got some skills. So let's then report that dog1 log skills. Got a capital K in there. But let's also say let's log a couple of these. Well, actually, no, let's not. Let's do it without it, and then we'll pop it back in there. All right, so we'll save, we'll run, see what we get, see if I messed anything up. Ah, there we go. All right, so Axel currently does not know any skills. We train, and now Axel can sit, fetch, follow, roll over, and code a website. Just a bit. Hey, I said dog. I said that dog's smarter than not dogs are smarter than everyone. Although some people. All right, so now so let's log these real quick. So again, this gives you the option. You can log it or not, but it does the work. So and sometimes this is helpful because you can actually set a mode. If you program and have some forethought when you're developing a program, you can actually set it up to detect if you have a global setting for like debug mode or developer mode. You know, you turn on developer mode on certain programs and you look at the console and it's going to spit out a lot more data than it normally would. Well, that's turning on a switch that has, you know, affects all kinds of hidden little, not really hidden, but, you know, if decisions. If debug mode equals true, we're going to log dog1.train. Else, just dog1.train. We're not going to log it. So that, you know, is an option for you know, providing for more output from your program when you're, you know, developing it, or even in the future when you're doing maintenance, because, you know, the SDLC, the software development lifecycle, it's a cycle. That's the idea. So you're going to be revisiting code in future cycles. All right, so now we just made it verbose by simply logging the return from our train function. We didn't have to. We could just tell it to train and do the work and be quiet. But in this case, I logged it so we can see Axel currently does not know any skills. Axel has learned sit, has learned fetch, follow, roll over, code a website. And now Axel can sit, fetch, follow, roll over, and code a website. Excellent. All right, fantastic. Now, break before we get into classes. All right, awesome. So let's do our basic little break here. Think of any questions you have about anything at all relating to our objects or prototypes and inheritance, anything like that. Feel free to post those during the break, and I will be happy to answer them. But once we get through those, we'll go right into classes, and I'll show you how to all the syntax. We'll redo that, but we'll do people and then employees and managers. We'll do some similar stuff using the new class syntax. Speak. Nice, excellent. Yeah, I think this is great. See encapsulation. So I was curious what it said about that. So like I said earlier, JavaScript wants to be like the big boy object-oriented programming languages like C++ and C# and whatnot, but it just wasn't originally designed that way, kind of like the original C language. C does not contain objects. It only contains structures, which are kind of like a dictionary, like a very basic object, but with no functions, no methods. In true object-oriented languages, encapsulation is also sometimes referred to as the data hiding. And what it is that you're really trying to You're really trying to protect access to data at all costs. So I think I gave this example the other day, but for example, not just anyone should be able to go in and say employee1 dot pay rate equals $100 an hour. You should have to be forced to go through a validation of your authenticity and authorization to make that change. So by hiding away access to data, by making it private, you have to go through methods of that object in order to modify the data. And that's where security programmers go into that method and they program validation of your username and password and all that stuff before, and then validate your credentials to see if you even have permission to make that change. And assuming everything is, everything's okay, then you're allowed to access the data, again, still using through that, that method. So it allows us to protect and create security and access controls in JavaScript. Otherwise, someone can just come along, write their own object, inherit your main object, and then they can control and modify and do whatever they want to your program. So when you're trying to make games or whatever, then it's very easy to cheat when you can just go in and access any of the variables. So I did read that it has already been proposed that the pound symbol will make object attributes private. So you can't directly access it using the dot operator. So that means, and let's see, let's test that out real quick because I'm curious if that works. But back to real quick, but yeah, the idea is that we're housing our data and our methods and functions, which are methods, within a single object, and each one of those objects should be managing itself. So even if I have an object with an array of objects inside, each of those objects inside are still kind of managing themselves, managing their own data, managing access to that data. So JavaScript is becoming more and more like a true object-oriented programming. The first big step was giving us classes, which is what we're going to go through here next. The next step is private variables, which we're going to see if that actually works here. So let's try it. So let's go to the dog prototype, or not the prototype, the constructor. Let's say this dot, I think it's going to be pound this dot. No, probably not going to be that. It's probably going to be this. I actually haven't seen it used yet. So let's see, say, whatever, it's equal to Spark. Okay, so now let's see if we can access it. So if we can access that, we should be able to say, dog1, actually log, dog1 dot bark. I don't know if we'll see if it's even gonna. Okay, say must be private field. Say, oh, private field. Okay, must be declared in an enclosed class. Okay. So we're not there yet. We're not using classes. So it looks like it might work, but it doesn't work using constructor functions the old way. So that's something we're going to try out here later. Now, where did I just put that so I can get rid of it? There we go. Get rid of that. And we'll get rid of that. Okay. So now let's get into classes. So we're going to do the same, pretty much the same thing, but we're going to do it with a person. So we're going to say, I'm going to start with class. And remember that a class is like a blueprint for a house, except it is for an object in memory. So classes, we create this structure as a class using the class keyword, like so. We'll give it a name, person. And we treat this, now we treat this kind of like a small, little bit kind of like a small program, in that we then have our constructor, which is just called constructor. In many languages, the constructor function is also typically the name of the class. So in C++, C#, all these other object-oriented programming programs, you would have a method like this, person. But instead, we just have constructor name. And you're not going to call it constructor later. You're actually going to call it from the person. So that's where you kind of see that similarity there. All right, so we got our class. Let's spread this out just a little bit. Okay, so that's class, constructor. So now this behaves like a regular class or object constructor. This dot name is equal to name. It's really easy. So this is our basic constructor. And this is going to be, remember, this is the base class for all, people-ish objects in the system. So everything that's going to be, represent a person, an employee, a manager, a leader, a CEO, CFO, whatever. This is going to be the very base class. So everyone's going to have a name. And think about other things that everyone in the company is going to have. Everyone's probably going to have if it's an employee, if it's belongs to the company, then they're going to have an ID number. But we're not sure about that, right? Because what if it's a customer? Customers are people, so let's leave that out. Right, age would be another one. Let's see what else. So social security number, if you're collecting social security numbers for whatever reason, every person in, the US has a social security number. Oh boy, now you're getting politically correct. There you go, start date, job title. So again, think about this. We're still talking about general people. So this could be a third-party contractor, could be a customer. So customers don't work for the company. Everyone does have an address though, right? So let's do, we could say, I'm gonna comment it out so we don't use it, but we could say this dot address is equal to address. And we would put that in our parameters there. So when you start building a class hierarchy, you're obviously going to do it long before you even start typing code. You're going to plan it out well in advance before you even type a single keyword. But what you're going to do is you're going to think about all of the very basic generic values and attributes that every person in this case is going to have. So that way, whether down the road, whether we're talking about a manager or the CFO or a low-level employee, they're all children to some degree of person. They all were derived from person way back up in the hierarchy, which means they are all going to have those generic values. Right, there you go. Now you're thinking email, phone number, contact information. Absolutely, those are going to be good generic ones to include for a very base class person. Now this is where you set up all your attributes. So let's go ahead and do address. Let's go ahead and put it in there. Why not? I just didn't want to have to come up with an address, but we'll come up with something silly. And let's do an email. We'll just start with that. This email. So now everyone in this entire system using this code is going to have those basic attributes. They're also going to have any methods that we add to this, which we'll do here in a second. Okay, so that creates our object's attributes. So when we call this to create the object, it's going to call the constructor function. It's going to create this.name, this.address, this.email, and then it's also going to associate all of our functions here. So now we need a function. Yeah, there you go. Exactly. So nice. Yeah. So, and that can actually, I would make a note because of the loose typing of JavaScript, I could try to pass in an object. I could also try to pass in a string, but my code, my functions may be written to handle objects. So if I try to pass in a string, it's going to have an issue. So if I was developing this, I would leave a note, pass in as object. So that way, if I wrote a function down here that prints the address, we know that we're going to treat it like an object and not a string. So something to think about with how loose our typing is. Other languages, you have to specify this is going to be a string, this is going to be an object, this is going to be a string, and they must be those data types. But JavaScript doesn't worry about that kind of stuff most of the time. All right, so let's see, an object within an object. Yeah, absolutely, Carlos, because that's what that can become. So this could be, well, actually, let's do that. Let's just make that an accessor method. We'll use that here because I wanted to show you guys accessor and a mutator method. So let's leave it as a pass, and we're not going to pass it in. So it's just an object. So yeah, object within an object, no problem. We got that. Okay, so now if this was going to be an object that I wanted to instantiate, we would do the new and then call the object. But that's a little bit different. We're going to fill that object with data later on. Excuse me. Okay, so now we need to write let's just do a basic speak so the person can say hello. That's how you start. No function keyword, no weird extra syntax, just speak, parentheses, curly braces. But making sure that you are still within the scope of the class definition. So this is the end of class definition. And this is, of course, the beginning, let's say start of class definition. Okay. So everything we define within those curly braces is a member of the person class. All right, so our speak, the speak is going to simply return, and we'll do the same syntax. This.name says hello. Nice and easy. And that's it. No person.prototype is equal to whatever. And you'll even see the inheritance is even easier as well. So real basic, nice and easy. Syntax already so much cleaner, right? We've already created it. It's nice and clean and easy to see. And I typed a lot less. So we're already done with our first object with the same function here. Now let's go ahead real quick and let's add another function to set the address. So let's do this is going to be called a mutator method. Mutator in that it's going to mutate the data inside the object. Mutate in a controlled way, not in a kind of way. So let's do set address. Those are usually the methods that start with set, and then the other ones are going to be get, but we're starting with set. And we're going to pass in the object, which will be address. Let's just do adder. And then we can say this dot address is equal to adder. And we'll say pass in as object for anyone who's paying attention. All right, so that's a mutator method. Again, if classes would go to the top of your JavaScript for other developers to see. Yes, absolutely. You'd put all your definitions up at the top. So, weird. Yeah, I'll post it again here. Should be on the same one, yeah. Oh, weird. Yeah, it changed. I don't know why it changed. Sorry about that. It went from 12 down to 11. All right, so now the new link should work. All right, so that's basic set. And if you wanted to, again, return, you know, we'll report this dot address object, which probably won't work as we expect. I'd have to have a little more code in there, but that's the idea. Then we can tell it to report. So again, that's just being verbose. If we wanted it to be address, but otherwise, if you just pass in the new address, nope, I got it. Okay. So then the other one is a accessor. Let's do mutator accessor method. And the accessor method just simply returns data from our object. So we will say get address, no parameter, unless we want to control how the address is formatted. That might be a parameter to add into a get, but otherwise it's just going to return this dot address. That's it. That's the basic idea of a get accessor method, is it simply returns the data. It retrieves the data for you. So if we program these as hidden, or which we'll actually do, we'll do that with address since we built the accessor and mutator method. If we give it that pound symbol like we tried earlier, it should block me from directly accessing it, which would force me to then go through the set and the get methods. Okay, so I think we are done. Yeah, so let's go ahead and create it. And yeah, okay, let's create. So we're going to say, great basic example. So we'll say const person1 is equal to, and then our basic new person, and we'll call it Nathan. And then what was the next one? So we're going to say email. So we'll do so, okay. So that should create our person1. Let's run it and make sure. Nope, I already had someone, person1. Oh, that was in person up top. All right, so let's do, let's change this. Just say person with a lowercase. There we go, okay. There you go, my person1, there you go. Perfect. All right, so now let us, so we created our objects, now we're going to call it. So we're going to say person1 dot, and then let's say speak, and it's just going to return it, so we need to log it. So we created a person with that data. Now let's say, let's just go ahead and make sure it's going to run right. Undefined says hello. Hang on. Look at my code here, make sure I'm doing this right. Yeah. person one, speak. This dot name, person. Maybe I'm still getting an error issue. What is going on? All right, so let's clear this. I'm gonna get these logs out of here so we don't have so much output. Misspelled constructor, could that be it? It certainly could be. Yeah, yep, sure is. Constructor, thank you. There we go. Okay, now we're good. So everything's happening in the background. Everything's happening the same. We've got our attributes inside of the object. It's just the difference is we're just using a class class syntax as opposed to just having a constructor function. Now, the real benefits. Let's actually go ahead and do our person one dot. Let's log it. So the real benefits come in when we start doing inheritance, but let's test out our private variable option here. Because remember, it was proposed, so it's not a part of the JavaScript standard yet. Let's say address. So we're just going to say address. We're going to try to access it directly after, of course, we assign it an address. Well, actually, let's see if we can do person one dot address is equal to, and we can say street 123 Happy Lane. First, you need to sound that in quotes. And we'll say, well, it's street and then number. I already got the number. Oh, goodness, city. Brain's not working that very well today. And state. There you go. And we'll go ahead and stop it there. So state. You guys get the idea. By the way, just in case you are worried, I'm good with all the fires going on. For now, I've had so many people across the country call me and my husband asking if we're okay. We're fine for now, although I am completely surrounded with smoke. All right, so let's see, person one address. So we passed in the address. Now let's see if we can log it and access it, assuming it even works. Perfect. All right, so there's our object. So that right there, that is directly accessing an attribute of an object. The idea of encapsulation is we should be able to prevent that from happening for security reasons and data integrity reasons as well. So, because what if somebody put in a properly formatted object? You know, so one of the reasons we force people, one of the other reasons we force people in other programs to go through accessor and mutator methods is also to validate the input format. You know, what if we're setting a pay rate, but someone puts in a letter in there? You know, you need to be able to have code to validate before you write it to the object. So in this case, let's set our address as private by adding the pound symbol in front of the name there. And now let's see, we'll probably get an error. At least I think we should. Yep. Must be declared in an enclosed class. This.address. Yeah, so it says, nope, not happening. Why doesn't your string on line 96 one speaks, oh, 86, gotcha. Because I didn't log it. Actually, I didn't even use that function. I'm bypassing the accessor or the mutator function, and I'm accessing it directly. So now, because I set address to private, now I have to go through there. So now you're going to see that I'm going to log that. Because remember, oh yeah, right you should be seeing it right here, but you're not, because you're, again, directly accessing the attribute. So it's not going to do any of this. It's just going to directly set it. So let's get that out of there. And we got to get this out of here because that doesn't work. But I'm going to copy that object. So now let's actually use the person1.setAddress. And normally on IDEs like VSC, as soon as you program that up in the objects, you're gonna get autocomplete. So you start saying person1.set, and it's gonna pop up with your objects methods that you've defined. So you can really start using those the tab key to autocomplete. Set address. It's just that this code pen doesn't do that for us. Pass in that object. So we say set person1.setAddress, pass in the object. Set address is going to take it and assign it to this .address. Then, oop, what the heck did I just do? And let's log it so we can see that we did actually successfully mutate the object. So let's clear, and we call everything. Person1.setAddress, person1 speak, set address, yeah. So we should see the new address is, hang on, what's going on? Line, it's private field syntax must be declared in an enclosing class. Maybe it's, oh, you know what I bet it is? Yeah, we put the pound there. We're testing out the private function, but I think I probably have to do it here as well, maybe, in the actual accessor and mutator methods. So let's run it again. Nope, same deal. Okay, so maybe it doesn't work yet. But what I was trying to show you is protecting that data to force other code and other objects to go through the mutator accessor methods. So it's not required in this case, but let's go ahead and use these. So now we should be able to get some output. All right, so there we go. So it did, the address is this .address. I had this issue earlier in some code. Let me see, what did I do to fix that? I don't know if I did fix it. But we would just need to fix this right here is the only reason but the data is there. Because if we directly access log person1.address, then we should get the data. So let's run. Yeah, see, so it is there. It's just my output formatting is bad. No, because so I could call it back from adder. I could call from adder, but here's the theoretical drawback to that. I'm not actually verifying that the data is in the object. All I'm doing is spitting back out the parameter. So what if we had an error here? And then I just say, oh, the object's new address is what we passed in, but yet it might have had an error and didn't actually get logged, or didn't actually get stored. Probably unlikely, but just to see the results, so what we should be seeing. No, it's doing the same thing. Because we're calling it for object within an object. So oh, okay. Aha, okay. Gotcha. All right, so we'll circle back to the private field and try it again at the end here. I don't want to get stuck on it, and I'm looking at my code here. How did I get it to report? Oh, that's what it was. For some reason, JavaScript, when you get object, little object, capital object, when you get that output, it's just saying that that's just the generic string output for objects. So I would need to do this.address, and then go ahead and select the thing. So I'd say street, and then do that again. This would be city and state. Now we should get some proper output. There we go. Now we're good. So yeah, you can't. Yeah, exactly, Isaac. That's what it was. I couldn't remember. I did it earlier today, and it was driving me crazy. I'm like, I know this works. You just can't spit out an object from inside an object like that, because the generic toString function just spits out object. So you just got to be more explicit on what you want it to put out there. Okay, so fantastic. We've created our class up here. So this is our entire class definition. So that is, yeah, right. You have to define your own toString function and override it, and which we can do easily to override objects. We can override the toString, anything like that. So I'll show you that here in a little bit with speak. We're going to override speak in different objects to change how it behaves. And then we can, I'll show you polymorphism again, so you can see how that is beneficial. All right, so let's get this out of here. All right, so now class inheritance. I'm fascinated to try the private thing, but I don't want to run out of time. So class inheritance. So now we're gonna make an employee. So we'll say class employee, and I'm already forgetting my syntax. Okay, then just curly brace, and then now we say constructor, and the employee is going to have name. We're going to do email, and let's also do. Let's do EMP-ID for employee ID number. And then let's also do department. All right, so we'll go ahead and, so now, inheritance. So now we need to inherit a class onto this new class definition. What's the keyword? What keyword do you, oh my goodness. Where? Oh, geez. There you go. It extends. So employee extends person. Right? I got that right? Just double checking my notes. Yep. Extends person. It doesn't turn blue. So that's the first step. So what that does is that goes ahead and that creates the bind between the two objects. So it, it kind of replaces, there's my text there, extends, automates the copying of the prototype and binding of the constructor to the parent object. So it handles all of that binding where we have to say, the parent.call, and then this, and then our attributes. So that all gets handled for us through extends. The employee.prototype is equal to object.create, person.prototype. That all gets automated as well. So we don't even have to worry about that anymore. And it still takes advantage of the memory benefits of using the prototype. So it does still put things on the prototype. Now, we're not done, though, with inheritance. We need to call the parent constructor. Now we use a special function call called super. Sometimes we call a class hierarchy, the parent is sometimes called the superclass, the parent class, and then the subclass is the child class. All right, so super, and then we pass in name, just the attributes for the parent class. So name and email. That's all we need to set up our using the parent constructor. Now, if these were all connected into a single attributes object like I did last class, then you could pass the entire thing in. You don't have to delegate it out and separate it out unless it wants them, actually separate, in which case you'll have to do that. So just keep in mind how your functions are expecting data. All right, so the super instantiates the parent attributes for this current object. All right, and that's all you got to do. Super, and then pass in the attributes for that parent constructor. So now let's go ahead and make our own. Let's do an override function. So we'll make override method for speak. So we're going to do our own speak method here. And oh, hang on. I'm not done yet. I'm not in the methods yet. Hang on. We still haven't even set up our unique attributes for employee. So now we say this dot empid is equal to the empid. This dot department is equal to department. Okay. Now we got our unique attributes. So now we have unique attributes for this more specific class. Okay. So now these give us our parent class. This gives us the unique characteristics for this child we're creating. Now we don't have to do anything else to inherit the methods. So speak, get address, set address, all of those are already being inherited through the extends keyword. But we can override speak by simply writing a new speak function using the same name, and it will overwrite speak. So in this case, we can tell it to return. Let me go ahead for time's sake. Grab this statement here. I know I'm slow hitting the $ and curly braces, so I don't want to waste everyone's time. So this dot name is responsible for this dot department, D-E-P-T. Now notice again, name, this dot name, that gets set up from our super call. That's why you don't see it in here, but it is still a part of this new child object. So this is called a override. An override is simply using the same function name in child objects, but changing its behavior. And remember, think back to when I showed you polymorphism. You create an array of these objects, and you can put it to a for each loop or just a basic for loop and say array element I dot speak. And every item will invoke its own speak method using its own unique instructions. So even though you have all these different objects in the same array, they're all going to, and you're issuing them the same function call, they're all going to behave appropriately according to their own design. All right, so speak, no problem, we got that. And now let's go ahead. Is that everything we wanted to do? Well, we could do it. We could then do set department, get department. Yeah, override. Override changes the behavior of a parent's inherited, well, of a child's method inherited from the parent. So employee inherited speak from person, but we are now overriding and we're changing the speak function. It'll still respond to speak just like a person object will. The employee object will respond to the call speak, but it's going to behave differently for each object. And I'll demonstrate that here at the end, or actually not at the end, but here in a few minutes. Okay, oh, we got to clear, save, run. Yeah, you bet. Okay, so now we're good. So now let's go ahead and create another extension. Let's create manager. Now, think about hierarchy. What do I want to inherit onto a manager? Do I want to inherit the employee object, or do I want to inherit the generic person object? Think about it. What would be more efficient and more effective for me as the developer? You can do both, absolutely, but which one would be better? That's right. It should be employee, because employee ID, department, and the new speak, that's all going to be usable by a manager, because a manager is an employee. It's just a more specific kind of employee, right? So that's, again, going down the hierarchy of our classes, the parent superclass up top, base person, then we define it as an employee, and employee can then be inherited to managers, CEOs, maybe not contractors, you might do something different. And you can inherit employee onto all kinds of different, more specific type of employees. You know, factory workers, maintenance, managers, regional managers, all of those objects would inherit from employee. Yeah, janitor, exactly. Will manager inherit person through employee? Yes, absolutely, Gina, because remember, it's going to be like a chain. So let's do that real quick. Let's go ahead and set up the constructor so you can see extends employee. Ah, my goodness, employee. And then we'll set up our constructor. We'll say this one's going to be name, email, EMP ID. This is the point where I'd start using attributes as objects. Department, and then we'll stop there. I got something else I'm going to do. Yeah, very true, Bradley. But and it's not just JavaScript either. All programming languages that are object-oriented follow this very cascading kind of effect. But that's a good connection to draw, Bradley. Very nice. It is kind of a cascade. The hierarchy of our classes, our parent classes, down to our child classes, that is a cascade effect. Well done. All right, so our constructor, we're going to call super again, name, email. But which super am I calling? Yeah, cascading JavaScript. Nice. Perfect. So which constructor function at this, when I call super, which one's being called? There you go, Alex. It calls the direct parent. Not the grandparent, not the great-great-great-grandparent. It calls the next parent up. So in this case, it is going to call the employee, so we need the rest of these parameters there. So right there, I'm going to just stop right at that moment. So this is going to call, when we go to create a new manager object, it's going to do its extends on employee, goes ahead, does all the binding, and then we call our super. Super points to employees constructor. We go up to the employees constructor. What does it do? Boom, it immediately calls its super constructor. So then it goes up and it calls person. So then person, oh, where is it? Person constructor executes. Then once we're done with this command. So then we execute these. And then when we're done, then we come down and we execute these. This dot employees is equal to like so. So it is a chain link effect. It is a cascading effect that each constructor calls the parent constructor, calls the grandparent constructor, calls the great-grandparent constructor until it finally gets to the base class, and then it comes all the way back down and finishes up all the constructors, setting everything up along the way so that we now have this very robust, detailed object. Goodness. All right, excellent. So now, let's see, manager. So let's just do real quick set department, DEPT. This dot department is equal to new department. So real easy, very basic. And then we'll do a get department, again, just for review. Get out of here, fly. Don't really need a input unless you want to pass in a callback function to have the return data, go somewhere special. what does line 131 do? 131. That sets up an empty array called employee. So that's going to be the manager's employees. I didn't. He's still floating around here. Come. Yeah, now I'm going to knock over my drink. Got it. All right. So all it's doing is setting up an empty array for the employees that this manager is responsible for. So that's just setting up an empty placeholder to put in, to link in objects inside of it. I got him. He's gone. He's now being absorbed into the microfiber he got squashed on. Man, those things are super absorbent. Yeah, you got it. So now department set department get department return this dot WebPT. All right. So again, accessor mutator method, very standard, not necessary in JavaScript. You'll probably learn some other things in when you get into the or advanced messages. And so let's see. So the next one is let's overload, or I'm sorry, override. So now we're going to override. Actually, where is? That's what it was. I'm sorry. I needed to add one more. So I actually wanted to do overseas. And let's actually set that to overseas. So overseas, who they oversee. And I'm going to say, because actually that doesn't work. And I tried, no, actually, hang on. I think I got this simple because I messed up earlier with my code. So let me try this. So I think it's employee is equal to oversee, because I'm going to be passing in an array of employees. So this is going to be an array. So we can say map E to E. So that's just going to essentially take each of our elements from overseas, from our input array, and pass them into the employee array. And we'll see if that works. I was having an issue, so I did an if setup, which is not needed. So, all right, so that's going to set up our employees there, if we have any. Now, let's see, override. So let's override speak one more time, because again, we got other stuff to report. So speak, let's grab my function here. So we got to do this a little bit differently, because again, we're like we got the object from the address earlier. We would get the same thing from that array list of employees. So what I did here is I've got string, let string equals this dot name is responsible for overseeing this department, and the employees are, and then it does the for each and just spits out the name of each employee. And then it returns the string, so we need to log that speak. So we've got 3 different versions of the same function. And if we add all these to an array and issue the speak method, or the call to speak, they're each going to behave as each of them should. So you're not going to get people that are behaving like managers. You're not going to get employees that behave like managers. They're all going to behave like they should. So let's create some people. So let's say let person 1, oh, let's do 2 now, is equal to, and let's just do a basic person, oh, new, person, oh man, person, let's just say Sally, and then we'll do let person 3 is equal to, we'll do another employee, new employee, and that's going to be Carlos. All right, so we got Carlos in here, and Carlos has a fantastic email, email at emailprovider.com. Perfect. And then let's do, so we've got 3 people now. We got person 1 up above, up here somewhere. There he is. So we've got person 1, which is just a regular person. We got person 2, which is just another regular person, Sally, although I got a, no address, right? Yeah, person's just a name. And then let's do one more employee. Why not? Person 4 is equal to new employee. And then after this, we'll create our manager and we'll pass in these guys into it. Should it be this dot department equals str? This dot department. Where are you referring to, Claire? This dot, oh, this dot department. I'm sorry. Yeah, you are correct. Yeah, I fixed it earlier, but obviously I wasn't paying attention this time. Thank you. Okay, so now employee, let's do one more. Hey, Claire, since you just did so awesome, I'm hiring you. Jackson, and then we'll say, we'll just give you a basic email again. I don't care. Let's just get it in there. Okay, now let's create our manager. Let manager1 is equal to, and again, these names here, guys, you can make those names whatever you want. I'm just trying to keep it simple because I'm not very creative. I'm artistic. I'm not creative. And yes, there is a difference. All right, so now we're going to say new manager. And what all do we have to provide? We got all of our variables there for the manager. So let's say the name. Who wants to be the manager? Seth. Thank you, Seth. All right, so now we're going to say manager at company.com. That's your email. Oh, wait. Am I missing something from employees? I am. I sure am. Employee ID and department. We would have figured that out after we got error messages. Okay, so employee ID number is going to be just, let's do 1, 2, 3. And department is going to be Carlos in development. Research and development. Okay, now Claire is going to be, let's do 1, 2, 4. And Claire, how about you're going to be in IT support. Then, since you guys are all kind of in the IT, so since you're all in IT, you're going to be, so Seth is going to be your manager. So we're going to pass in, well, Seth is going to have 1, 2, 5 as your ID number. And then your department is just the IT department. And you are going to manage person 1, person 2, person 3, in person 4. For some reason, I feel like my syntax is off, but I'm just having a brain freak. Okay, let's see. Okay, so now let's go ahead and log these just to make sure we're in good shape. So we'll see the results, home, delete. Log. We're going to log each of these individual people, log their speed, of course. So person 1, no, that's 2. We already heard from person 1, 3, 4. And this is going to be manager 1. So let's see what we get. Okay, so I'm gonna, for the sake of time, I'd have to trouble. It is console log, but I would copy that over from my prep code. But it'll give us the same error. And the reason we're getting the error is that it's not coming through properly as an array. Oh, overseas.map. So I'm going to do it. I got this to work earlier, so I'm going to do it that way. So this employee, we'll set it to an empty array, and then we'll say if overseas.length is greater than 0, then we'll go ahead and map it. And we'll say this dot overseas is equal to, and it's not overseas, is it? It's employee. It's equal to overseas.map EE. All right, so now let's see if that works. Clear, run. All right, so let's see, 145, which is now. Oh, is it this one? Yeah, that's the one I think is the one not working. 147 here. So this dot employee. Oh, yeah. Okay, wrong name. That's the hazard of copying and pasting from my code earlier. Thank you. You guys are awesome, paying attention. There we go. Okay, so let's see what we get. So that was the original person one. This is the original person one speak. That's us setting its address, and it reports back, just being verbose. Sally says hello, so that's person 2 here. Person 3, Carlos Ramos, is responsible for development and research and development. Claire Jackson's responsible for IT support, and Seth McPherson is responsible for overseeing the IT department and the employees Nathan, Sally, Carlos, and Claire. Now, that's a lot of log commands. Make our life a little easier. Everybody? Yep, 1 through 4. Perfect. Now, how would I tell them all to speak? What would be my next command? Because I put all these objects into workforce as an array. So remember, a workforce is an array. Not quite. You got to iterate through it. Because workforce is an array, which doesn't have a speak method. There you go, Jose. Now you're thinking, yeah, we're going to use a for each. So now using a for each on workforce, we're going to log workforce dot for each. Yeah, there you go. Nicely done. So for each. And then this is going to be, let's do EMP. And then EMP is going to be, we're going to say dot speak. Like so. So the for each is going to run through each of the employees inside of the array. And it's going to call each of those employees speak method. Now, we got persons. I should have named these employees, employee 1 or EMP1, EMP2. Let's go ahead and do that just to illustrate it a little bit more. And we'll ignore the 3 and the 4. It's going to be 3. So we can clearly see that these are different objects. Let me make sure I got no errors. Okay, and then, okay, so now we're here at undefined. So now let's see. So those were these guys, workforce, for each, EMP dot speak. What am I missing? I shouldn't be. I shouldn't be losing. Because I run this. Let me see what I did over here. Hang on. Oh, yeah. Because so okay, I know what's going on though now, but it's with the position of log. For each doesn't return anything. Gina taught us that in our last class. The for each does not return anything. So I put that in the wrong space. Log, like so. And it may try to return log, so we'll see if gives us some weird output. Nope, it worked. So right there, I did all this log, 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 when really you just throw them all into an array and pass them into a for each and call that overridden function or method, sorry. And you can see they all responded appropriately. They didn't all use the parent one. They didn't all just say Nathan says hello, Sally says hello, Carlos Ramos says hello. So they didn't all behave like people. They behaved like what their class definition was. So we have these two people here, we have these two employees here, and then the last one is our manager. So, wow, I'm out of information. So now let's do a break, and you guys come up with questions. Let me know if you want to see examples of things. Let's try some weird stuff if you want. It's our last 30 minutes or 20 minutes together, and we don't have to go on break if you don't want to. We can also just cut it early if you want. But you know, what do you guys want to see? What do you want to hear about again? Yeah, this, so I can cover it again. Absolutely. So polymorphism is we put all these objects into a single array, even though they are different classifications. We've got two people, two employees, and a manager. But because they all are derived from the same parent, actually, no, that doesn't matter. Because they all contain the same speak function, the overridden speak function, when you run through, when you iterate through that list of objects and call their speak function, they're actually calling different functions for each of those objects. But we were able to treat it all as a single thing, as if they're all an employee or they're all a manager. So it allows you to issue a single command, a single function call to all kinds of different objects and allow them to, you know, respond appropriately. Yeah, you could do, well, I guess what you would be doing is you would just do a for loop in that case. If you wanted to just log each one individually, you wouldn't use a for each. So then you would say for each, as long as I is less than workforce.length is I plus plus. And then from here, you would say workforce I dot speak. Actually log that too, log. Like that. So then we're still technically doing the exact same thing here with the for each, but you are more explicitly calling each one individually. I mean, it's still kind of exactly the same. Calling them truly individually, not using the benefits of a for loop or any kind of loop, is this right here. Just call, you know, manager1.speak, person2.speak, you know, although of course I've changed these to emp3 and emp4. Seth, so what would happen if the manager did not have a speak function? Would it default back to the employee or person? It would default back to the last override. So again, since it is hierarchical, it cascades. So the last override is what's going to take place. So if we did, and let's go ahead and do that, we can try that. Well, the direct parent of manager is what? Employee, right? So the direct override of manager is going to be the employee. So if we go to, where's our manager? Manager. So let's comment this out, and let's run it again. So we should get an employee response for you down at the end. There you go. So yeah, it just defaults back to the next parent's override, because if you think about it, manager inherited everything from employee, and employee has its own unique overridden function. So if I had inherited from person, then it's going to use the person's original speak function. So you are directly inheriting from employee, which overrode the speak function. Okay, so but could you do a for loop with an if statement to allow you to pick which one you have to speak, right? Yeah, you could do that, absolutely. So you could say that, so if workforce I dot we would have to have something to specify, well, let's say type, hang on, JavaScript type of, okay. So if type of workforce I is equal to manager, oh, I think it's going to be a quote manager, end quote, log that speak. So let's try that. Let's uncomment this so that we have our unique speak. So hopefully, if I did this right, only the manager will speak. Well, everyone's going to speak the first time, and then the manager will speak again, hopefully. No, it did not. So let's do real quick just to figure out what does type of return, type of, and we'll say manager one. Let's see what we get, run. Come on. Type of manager one. Oh, you didn't log it, silly. Of course. It should be like everyone's default to tell me to log it. All right, so well, shoot. It just says object. Log. JavaScript, return the class of an object. Let's see if we got a function for that. How to get the class name of an object. Let's see if we can do that. Ah, there we go. Haha, perfect. Oh no, constructor.name. Let's try log, and we're going to try manager1 dot constructor dot name. Let's see if we get that. Okay, perfect. I was afraid we were going to get constructor spit back out at us, but the object's, the class's name, manager, gets superimposed over the constructor name right there. So that's why we get it. So that way we can say get rid of that. So now we'll say workforce at I constructor.name, is it equal to manager? If so, speak, or forever hold your piece. There you go. So that way you can tell only certain ones. So you could say manager, you could say, and actually we can make this easier on ourselves. Say let type equals current constructor's name, and that way we can say is type equal to manager, or is type equal to employee. So now we can see all the employees. So the people are going to be quiet, and all the employees, including the manager, should speak that second round. So yep, Claire, Carlos, Claire, and Seth spoke that second time. So selecting just certain class object types to respond to overridden method. Nice. Yeah, most likely. So let's copy our for each down there, and let's do. So essentially, we'll just take this entire for loop here and stick it in here. Now we need our curly braces around this function. Function there. Is that it? Yep, that's it. And it's probably going to make me put parentheses here too, because I've got the curly braces. All right, so let's see. What do we get? Yep, perfect. Same deal. So we got, uh-oh, hang on. What the heck? I are confused now. Okay, what do we got? We got going on here. So we got Nathan, Carlos, and Seth. So this is the first loop here for selecting just items. Then we got it again down here. Oh, hang on. Yeah, I don't need the for loop, do I? So yeah, for each, because the for each is the for loop. Yeah, you guys got it. I'm sorry, I'm not paying attention to you. I'm trying to figure out what's happening. So we don't need the for loop, right? Because the for each is the for loop. And we're going to say EMP. So for each one, and then workforce is going to get replaced with EMP. Workforce EMP. So yeah, you just got to treat it like a for each function, which is what I kind of didn't do. All right, so let's see now. Clear, run. So we should get nothing. Where is that missing? EMP. Yeah, that's the one it's missing somewhere, or it's extra. Okay, so let's do this. So that's our function right there. There we go. I gotta get rid of that. There we go. Now we should be good. Clear, run. All right, so those are basic outputs. There's the repeat from the for loop. And then here is the repeat of selected speaks using the for each loop. So absolutely, just about anything's possible. I say just about anything. Awesome. Anything else? Pretty fun stuff, right? I mean, interesting at least. May not be fun for everyone. But this kind of stuff is, I started out as an object-oriented programmer, so I just eat this stuff up, but it really, you can start seeing how you can build some pretty powerful software without really having to kill yourself coding it. You can take advantage of a lot of efficiencies through object-oriented programming and allow you to have a lot more organization in these potentially massively complex sets of code. So I hope you guys enjoy the rest of your Unit 1. You've got your build, 2-week build sprint, and then you're in starting in Unit 2. You know, Seth, it's actually the classes. That's really what makes it make more sense. It's so much simpler than doing it the roundabout way, you know, using the constructor functions. It also may sound a little bit more clear from me because this is the stuff I know. You know, it was really rough in CSS and HTML because I do more programming than website design. Even though I know HTML like the back of my hand, CSS, a little shaky on it, but I know it. But I'm really an object-oriented programmer, so this is what I really understand. Bradley, thank you for being an awesome student, and that goes for all of you. Like I said, guys, I've really enjoyed working with you. You guys are awesome, and I have no doubt that you're going to blow your coming instructors away. So just keep at it. You know, the biggest advice I can give to you is stoke that fire for your desire to learn and succeed in programming, because you're going to hit challenges that are going to really, you know, give you a stumble. So use the advice that we give to you. Take breaks, try it for 20 minutes, step away from it. That's what I actually did just last night. I couldn't figure out, I was working through the baseball project, trying to do the get winners by year. And I was just at a mental block. I couldn't get it. So I literally walked away from my computer. I went and played with my dog and came back and, oh, that's what it was. So definitely make sure to do that. And with you, Carlos. So I've really enjoyed it. I hope you guys enjoy the rest of your journey. I'm still going to be here. I'm not going anywhere. So feel free to say hi from time to time. If you want a second set of eyes on your code, feel free to throw it at me. If I got some time, I'll hop in and take a look. Hopefully you've picked yourself up, Jonah, and keep going. Amanda, it is my pleasure. I hope I did do a good job of getting you guys a nice start. Awesome. Well, you guys are awesome. Thank you, Danielle. Thank you, Grayson, Jonah, Anthony. Always a pleasure. Carlos, Seth, Amanda, Jonathan, Gina. Always the light of knowledge for us all. Thank you, guys. Jose. Do good work. I know you will. Keep at it, guys. Alex, Isaac, Bradley. Let's see, Bernard. Yeah, you guys are awesome. Well, if you don't have anything else for me, any more questions or anything at all, I bid you good evening, and you know the drill. Stay safe, wash your hands, stay away from people, wear a mask. And you know what? I'm going to throw something else in there. Tell someone you love that you love them. Make sure you do that. My partner says that after the end of every class. I'll say it at the end of the session of our time together, because it is important. Life is short. Make the best of it. And take care. We'll see you guys around. Bye, guys.